In lesson 3.1, we're in chapter 3, lesson 1, rational numbers and decimals. Now before I talk about rational numbers and decimals, I want to make sure we're clear on what standard this lesson is actually talking about. This is lesson standard 7, grade 7, NS, number sense, 2D. This is where we talk about rational numbers, all right, that terminate or repeat, okay? And we're converting rational numbers to a decimal using long division. So that we want to make sure we're really making sure we're understanding what it is we're trying to learn how to do, okay? And before I get into it, I want to make sure we're clear on what rational numbers are. Because when we talk about rational numbers, what we are actually talking about, all right, real numbers have to do with rational numbers, okay, like 5/6, 1.5, these are all rational numbers, 3.78, 8/3, these are all rational numbers. What makes them rational? The fact that we can identify exactly where these numbers are on a number line, all right? Rational numbers are any number that you can show on a number line. Cool? Now, that does mean that integers are also rational and real, all right? So we have integers like +1, 0, -3. They're just whole numbers that are positive or negative, okay? Now, that does mean we have other sets like whole numbers where you can have +3, +2, +1. We could even have 0 as a whole number because that's a whole lot of nothing, isn't it? And that's where we get natural, I'm going to put that in quotes, natural numbers that are only numbers that we can count like +3, +2, and +1, okay? Not 0. So all of these numbers are real numbers, and rational numbers are just anything that you can put on a number line. 3.78 can be put on a number line specific if we get really into it and we split this 3 and 4 into 10 groups, and then that's going to be a little bit more than the 7th group, 1 2 3 4 5 6 7, so it's going to be somewhere here, and then we can open that up and have a completely different number line, 3.7 to 3.8, and that's where we get 1 2 3 4 5 6 7 8 9 10, and this is going to be right there between 3.7 and 3.8. So you can go closer and closer and definitively say that 3.78 is that dot on this number line, okay? So rational numbers are numbers that you can definitively identify on a number line for sure, okay? So when we do look at how they talk about a rational number, they give a pretty complicated sounding one where it's a number that can be written as a ratio of A and B, where B is not 0. That, for our sake, is not terribly helpful yet. It might be in high school, but they give an example. 4/7 is rational because 4/7 can be turned into a decimal that is a terminating decimal that you can find on a number line, all right? So that's what we want to know about rational numbers. I'm going to go ahead and skip this example because ultimately what we're trying to do is we're trying to understand rational numbers as a decimal. So in order to write rational numbers as decimals, okay, we're going to be looking at what kind of fractions create a terminating decimal, like 0.3125 that come to an end, Okay, this is a terminating decimal because there is an end to the decimal, versus example B, which ends up being 0.393939 and so on and so forth, and it goes on forever. It doesn't ever stop. It goes on again and again and again, 393939. So what we do is we write 0.39 with a little line over it. Okay, that means it repeats forever. So that's essentially what these do, using long division to figure out if it's a terminating decimal or a repeating decimal. That's what we're trying to figure out. Cool? Cool. Now, if you don't remember how to do long division, I'm gonna have to put another video together that shows you how to do long division. But essentially the steps are: you divide, you multiply, you subtract, and then you bring down so that you can repeat this process. And you do it again and again until you figure out if it's a terminating decimal or a repeating decimal. And that's all I'm going to say about long division in this particular video. So here they have you practice using long division so that 4 divided by 7 is going to end up being some decimal that you write as a negative. 1 divided by 3 is going to be 1 divided by 3, and you're going to end up with a decimal, and your answer is going to be positive, whatever that decimal is. All right, so this is going to end up being a negative number, this is going to end up being a positive decimal, and this is going to end up being a negative decimal. So that's what you want to practice here. Now, in the next section, where they talk about writing mixed numbers, a mixed number is a whole number with a fraction. That's all you need to remember, okay? A mixed number is just an amount with a fraction next to it. So 1.5 is a mixed number. So in order to do this, what they're saying is they are rewriting the fractional part of the number as a decimal. So 6 3/4, notice they're only using the 3/4. They're taking 3 and dividing it by 4. And they get 0.75. And what they do is they then take that 6 and they add, not 3/4, they add 0.75, because 3/4 is 0.75. So 6 3/4 is the same as 6 and 0.75, which, what do you get when you add them together? 6.75. So this, honestly, if you know how to use long division to turn a fraction into a decimal, then a mixed number is just doing the same thing, and remembering, don't mess with the base number, don't mess with this number here, it's fine, leave it alone. Change the fraction into a decimal, and then add that number like normal, okay? So here we got word problems to help you practice doing that. And honestly, the guided practice, this is just more examples to talk through so that you can explain the steps for doing these things. Independent practice is the same thing. So next video, I'm going to get into adding rational numbers.